to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, Senior 4 Chemistry students. Welcome back. Alan is my name, still with you in chemistry lessons. So we are heading into Unit 17, which is about reduction and oxidation reactions under the topic of electrochemistry. Electrochemistry, as we're talking of what electrochemistry, we are dealing, or we shall be involving too much of electrons, electrons, electrochemistry, losing and gaining of electrons. So that is what we are going to be looking at in this unit of reduction and oxidation. As usual, I always start with giving you the key competence for you to have an idea on what is expected of you throughout the unit. So, under Unit 17, which is about reduction and oxidation reactions, we have one key competence which you should not miss, and that is explain the concept of reduction and oxidation, then illustrate with balanced equations relating to redox reactions. And with that as the key competence, we have objectives, quite a lot, because this unit is quite wider. So the learning objectives are, if I can paraphrase, you're supposed to explain in details what is a redox reaction, and that is in connecting it to the transfer of electrons, distinguish between a reducing and oxidizing agent as it regards to redox reaction, work out different oxidation numbers or oxidation states from which you can tell which element has been oxidized or reduced. Then use that prior knowledge to write balanced equations for redox reactions. Then we end up with the disproportionation reactions. So that is what we're going to look at. Of course, those are main objectives. We can't cover them in one lesson, meaning we have a few more lessons to go through under this unit. Please join me as we head to lesson 1, which is basically introduction to oxidation and reduction reactions. Introduction, we are just going to be looking at a few concepts in there, but mostly it is about defining what is oxidation, what is reduction, what is a redox reaction, and using day-to-day chemical reactions to illustrate what is redox reaction. And in that case, we shall be looking at rusting and writing the mechanism on how rusting occurs. So that is what we shall be looking at, and today's objectives, they are two. Of course, they are extracted from the general unit objectives. We are to distinguish oxidation and reduction in terms of oxygen, hydrogen, and the transfer of electrons. When we talk of in terms of oxygen and hydrogen, that is the other chemistry you've been looking at in your ordinary chemistry, in Senior 1, Senior 2, and Senior 3, and even partly some of the introductory parts of this Senior 4 chemistry. We've been defining oxidation and reduction, looking at only oxygen and hydrogen. But in this case, we are encompassing transfer of electrons. And when we define and distinguish those two words, then we can write the mechanism of rusting as we connect it to oxidation and reduction. So those are the objectives we are to work on. All right, let's take a quick revisit. You remember I just said that you've been looking at reduction and oxidation in terms of oxygen and hydrogen. Let's take a quick revisit. Oxidation can be defined in two ways, either in terms of removal or addition of oxygen, or in terms of addition or removal of hydrogen. So we are going to look at those two cases, giving example in each case, before we can go to the transfer of electrons. I pause. So what is oxidation as regards to oxygen? You've been doing this thing. We can take an example of that illustration. Most of us at our homes, we have charcoal, and we use charcoal stove, right? We use charcoal stove in cooking. So when you're burning charcoal to produce the heat for us to have the food cooked, what is happening? There is a chemical reaction. Charcoal is carbon, burn it in oxygen to form carbon dioxide. So there is a chemical reaction. In that case, that is oxidation, because we are adding oxygen to carbon. And so we define oxidation in terms of oxygen as the gain of oxygen by a substance. This is a day-to-day life activity, cooking of food using charcoal stove. You see, so charcoal has been burnt in oxygen to form carbon dioxide. We call it oxidation. It's not necessarily about carbon. Bring any other substance. When you burn it in oxygen, then we call that oxidation. What about reduction? Just the opposite. Flip the coin. If oxidation is the gain of oxygen, then reduction is the removal of oxygen. Using same example, copper 2 oxide, we normally say copper 2 oxide has been reduced to copper as a metal by carbon. In this case, carbon takes oxygen from the copper oxide. Using just this example as you've always looked at. So that is oxidation in terms of oxygen from your ordinary chemistry. Now let's go to hydrogen. Can we also define oxidation in terms of hydrogen? Yes. Hydrogen gas. So when you remove hydrogen from a substance, that is oxidation. And when you add hydrogen to a substance, that is reduction. Take a close look at that equation. You can form nitrogen from ammonia. You know ammonia, normally when you urinate and you keep urine in your house for a few hours, maybe 6, 7 hours, there is that smell of urine that comes up. That is the ammonia. Now, when you get that ammonia, maybe from the urine, and you react it with bromine, ammonia loses hydrogen to form nitrogen, and bromine takes hydrogen from ammonia. In that way, the loss of hydrogen by ammonia molecule becomes oxidation, and the gain of hydrogen by the bromine molecule becomes reduction. That is in terms of hydrogen, losing and gaining. If we can go to an advanced case that is in organic chemistry, we normally say that alcohols are oxidized to carbonyl compound. In this case, this is ethanol. Get the ethanol, the normal ethanol you drink, oxidize it by losing hydrogen, then it will form ethanol. Losing hydrogen becomes oxidation. Get this ethanol, add hydrogen back, you'll form the alcohol, which we call reduction. In this case, we say alcohols are oxidized to carbonyl compounds by loss of hydrogen and are reduced back to alcohols by the gain of hydrogen. So in this case, you see, when you're defining oxidation and the reduction in terms of hydrogen, it is just the reverse for the case of oxygen. So this is why you've been used to much more in our day-to-day science or in our day-to-day chemistry. Now we are going to advance a little bit and talk in terms of electrons. This is in terms of hydrogen and oxygen. Let's go a little bit and talk in terms of electrons. Of course, what I need to state in this case is we are not eliminating the definitions as regards to oxygen and hydrogen. No, it is not eliminated, but we are only going ahead deeper into the structure of the atom. In this case, I will bring it in this way. If you add oxygen to a substance, exactly what happens for oxygen to combine with that substance is what we are going to be looking at. And that is in terms of electrons. As we talk of electrons, we are dealing in terms of the structure of the atom. Again, we are not abolishing the use of defining oxidation and reduction in terms of oxygen or hydrogen. We are actually simply involving in electrons. So let's take a close look at that structure or that image we're having on the slide. You have a component A. Look at the slide there. You have the component A losing electrons, and you have B gaining electrons, as you see these illustrations. So when a substance loses electrons, we call that oxidation. And when a substance gains electrons, we call that reduction. If I can quickly summarize that. Oxidation, simple, loss of electrons. Reduction, simple, gain of electrons. One thing I need to bring in before we leave is the word anode and cathode. I know you looked at that in the senior 3 electrolysis, but I also have to bring it up. Anode, that is where you have the loss of electrons happening, and the cathode, that is where you have the gain of electrons happening. We can bring the whole of this information to our day-to-day activities, and we can do that by going through this activity. I call it lesson 1, activity 1. Take a close look. I'm giving you 30 seconds. Study those images closely. Study those images closely. We're going to use these 2 images to bring about what we are talking of, oxidation and reduction. And I'm pretty sure these images are not new to you. At least each one of us has ever seen a nail, the iron nail, yes. Your 30 seconds to study those images. So, what is image 1? We agree it's about the freshly made iron nails, right? So what about the second image? What is it about? That is rusty iron nail. This is freshly made, it hasn't been put to use. This has rusted. So with this, I pause. You notice that we are moving from the fresh to rusty component. So I leave you with a few questions. The first question is, these 4 questions will help us to understand and conceptualize the whole aspect of oxidation in terms of losing and gaining electrons. Based on the features as you see, what exactly is happening in our image 1 and 2? Which phenomenon that is taking place? And what do you think are the possible conditions that would cause it to occur? Take a close look, and this is even applicable in our day-to-day lives. You normally see these things happening. And using your S1 and S2 chemistry, still we can go through that. Part C, can we write the chemical equation that is happening? And what conclusions can we take? So we've seen those questions. Now let's answer each one at a time. I want us to go together answering each question at a time. 1, what is the phenomenon happening? Rusting. We all agree. Rusting, which is simply the corrosion of iron to form rust. And rust, we know it is hydrated iron ferric oxide. This brown layer that you see the difference in here. This brown layer compared with the steel or the iron steel that is clearly not put to use here. So we all agree that there has been rusting which occurred. Now, I pose another question. What are the conditions for rusting to occur? Remember, you recall your parents telling you, please keep the materials, the hose and the pangas we've just used in the house. Do not leave them out. Recall that? Did you ever ask why they're telling you to keep the materials inside the house? I'm pretty sure you're already having an answer. So the conditions for rusting to occur, we expect the presence of iron itself or any alloy, like the iron nails which are having steel, or the barbed wire, any component that has iron. If you have iron and you expose it to moist air, that is oxygen in the presence of water, it will rust. This will be observed after some time, maybe 3-4 days or even some weeks. So we've now seen rusting, we've seen the conditions, right? So can we write the chemical equation that is happening? If we can write the chemical equation fully well, then we shall have understood the oxidation and reduction aspect. But of course, for us to write the equation, we need to understand what exactly happens in the rusting process. We need to really understand what exactly happens in the rusting process. And we can understand that using this illustration. What do you notice? So, as we said, for rusting to occur, we need water, we need a metal which is made up of iron. So what exactly happens is iron loses electrons, which we call the anode side. It loses electrons to form cations or ions, which dissolve in water. The oxygen, presence of oxygen, which we call the air, takes up the electrons, and they form that rust oxide layer. Now, for us to write the equation, I want us to combine our mind in here and illustrate what is happening in. And I call it the mechanism of rusting. I'm calling it mechanism of iron rusting. So let's do what is happening in the rusting. As we've said, we need the site of the anode. Anode, this is where we have the oxidation. So the iron is the one acting as the anode by losing electrons to form iron 2 cations. It loses 2 electrons. Then we also have the cathode part where we have reduction. So on the cathode, on the reduction, it is happening onto the air, oxygen. Oxygen in the presence of water, 2 molecules of water, it gains 4 electrons to form a hydroxide, OH- aqueous. And because of these 4 electrons, that indicates each ion will lose 2, and to make 4 electrons, we need 2 iron atoms. Maybe a question would be, Why are we adding in 4 electrons? This is simple. If I can use this part, remember oxygen has 2 atoms combined to bring about the octet structure around one atom and another atom. So in this case, it will need to gain 2 electrons to have 8 electrons here, and 2 electrons to have 8 electrons. That's why we need 4. So when that happens, we shall have the site where there is that rusting, that brown, reddish-brown component. We call site of rust. The site of rusting. So this and this as the product of oxidation and reduction will combine. We have iron 2 plus, remember there are 2 ions, will combine up with 4OH to form iron 2 hydroxide. Now this is the salt that is formed first. This is a precipitate, or we call it a salt. So as it is formed onto the layer of the iron, on the iron nail, it undergoes further oxidation. We also have now further oxidation. The iron hydroxide as a salt in presence of extra oxygen, it undergoes further oxidation to form the iron 3 oxide. Here we have some extra water molecules. I call it X. Remember, water is available in excess. So, and this is the salt that you notice or you see as rust. This is basically the rust. And to balance this equation, there is extra 2 molecules of water that are being produced as a result of the oxidation of, the gain of electrons by this oxygen. Maybe before I leave on this equation, I want to show you something in here. The reason why iron 2 undergoes further oxidation is to gain stability. You remember, iron has 26 electrons, and as such, this is its electronic configuration. When it loses the first 2 electrons to form iron 2 hydroxide, it is only remaining with 6 electrons in its outermost shell, or the 3D. So it easily loses this single electron since it is paired up. So as the 3D has 5 electrons, which is half the number of electrons that can occupy the d orbital. And in that case, it becomes stable. So the loss of this extra electron is very, very, very fast, and that is why at this moment we have further oxidation. When it forms iron 2 hydroxide, it easily loses the extra electron to oxygen to form the iron 3 oxide, which we know as rust. Now, one other thing that I want to illustrate the presence of this extra water, I want us to find it on the slide. Check the slide. Check our slide. There is this extra equation here. This is where the extra water comes from. This water is where the extra water comes from to balance the overall reduction, or what we call oxidation and reduction, rusting mechanism. So this is what happens, as you've noticed on the chalkboard, as regard to what we even have on the slide. This is what happens for iron to rust. A few things you're noticing. We are losing electrons from iron metal, and the electrons are being taken by oxygen to form the rust that you see. So the whole process of rusting is oxidation and reduction reaction. And that is taking us to the last part. What conclusions can we draw? You're noticing that rusting is a redox reaction. It has loss of electrons, that is by iron, and gain of electrons, that is by oxygen. Then you have oxidation and reduction reaction, but in terms of losing electrons and gaining of electrons. So let's summarize up our lesson. What did we look at? 1, oxidation. You can define it in terms of oxygen or hydrogen. In terms of oxygen, it is the gain of oxygen and removal of oxygen as reduction. In terms of hydrogen, oxidation, you lose hydrogen. Reduction, you gain hydrogen. In terms of electron, which is the most precise because it goes deeper into what exactly happens, you have the loss of electrons, and reduction is the gain of electrons. So that is it for today. Thank you for being part of the lesson, and I hope you're still staying safe. I would wish to interact with you as we go deeper into the lesson content. Thank you, and stay safe. Bye.